Good morning, students. Today we are going to start with our first unit, that is matter in our surroundings. Now, this is the basic of matter that we are understanding was the base of matter, that what is matter and what categories of matters are there, then what are the properties of matter. These things we are going to study in this chapter, and in next chapter we are going to study about the elements and compounds, which is one step further from the matter basic. So first of all, let us write the definition of what actually do we mean by matter. So now what is matter, that we should know first of all. So matter is anything that occupies space and has mass. So we can write that matter is anything that occupies space and has mass. Now this is the basic definition of matter. Now this is known as matter. Now we can classify the matter. Now how can we classify the matter? So you should know that the classification of matter can be done on two bases. Now what are two bases on which the classification of matter can be done? So now let us see. The first on which the classification of matter can be done is on the basis of physical properties, means the outer appearance. On the basis of that we can classify matter, and in this unit we are going to mainly focus about the physical properties. The second is the chemical properties, means the composition of matter, and this major part will be discussed in the next chapter. So here we are going to study about the physical properties of matter, and in next chapter we are going to study about the chemical properties of matter. So these are the two things which can be seen over here. Now for our kind information, we should know first of all that what is the composition of matter, means of what is actually matter made up of. So now let us see the composition of matter. We can write here heading composition of matter. Now see, one thing is very clear, that we all know that matter is made up of atoms and molecules. Now this is the very basic thing that we know. These are actually the particles, means we can say that matter is made up of these particles, and these particles are actually what? See, matter is made up of these particles, and these particles are atoms and molecules. So this thing is very clear. Now we should know that how many particles are there in matter. When you talk about that the particles, so there is one example in your book also, that in one drop of water, when you talk about just one drop of water, now first thing is there, that is water a matter? So I think anything that occupies space and mass. So water has space and water has mass, so we can say that it is also a matter. Now we should know that this drop of water contains 10 to the power 21 particles of water. Now isn't it very amazing thing that one drop of water contains this much particles, which you can see inside the drop of water. These many particles are present inside the water. Now see, we are going to study about the particles, as now we have already talked about the particles only. So now let us talk and let us take one step further about the particles only, that what are these particles actually. So you see that we'll see that particles, are they stationary, means are they at rest, or are they mobile? Now this thing we have to explain with the help of one experiment or one activity that we can perform. In the exam also the question can be directly framed that prove that whether the particles are stationary or mobile with the help of an example or with the help of one experiment. Now see, there are two major and two very popular theories which can explain this thing. Now see, are they stationary or mobile? Which two theories prove that? The one is known as the Brownian motion. we are going to understand that what is the meaning of this Brownian motion, and the second theory that explains is the diffusion. Now what does these two theories explain? Means we talk about this Brownian motion and then we talk about this diffusion, but what are these two theories explaining? Whether the particles, are they stationary or are they mobile? That thing we have to study now. So first of all, let us talk about our first heading only, that is the Brownian motion. So I will write here Brownian motion, and now let us see that what happens here. Now this particular experiment, which is known as the Brownian motion, this says that when we observe particles of any matter, when we observe these particles in microscope means these are those microscope only which we see, when we observe these things in that, we see that the particles are in continuous motion. Means what does this mean now? They show continuous motion. Like if there are some particles, then it is like this, that one particle is going here, one particle is going here, one particle is going here, so one particle is going there. Like these particles, individual particles are showing the continuous motions. This is the basic thing, and this motion was first discovered by a scientist who was Robert Brown. Robert Brown was the one who discovered that these particles, when observed under a microscope, are in continuous motions. So we can say that because of this, these came to be popularly known as the Brownian phenomena, or the particles are known to show the Brownian motion. Now I have already told you that what is the meaning of Brownian motion, that the particles are in continuous motion when we observe them in the microscope. Now we can see the second activity also, or the second example also. So the second example says that when we dissolve these things, when we dissolve solid in liquid, now let us see what happens. Now suppose you take a beaker which contains the crystals of KMnO4. Now what is this KMnO4? This KMnO4 is potassium permanganate, and actually the color of KMnO4 is very violet. So it is like this. This is the potassium permanganate color. Now this is how the potassium permanganate looks like. Now what we have to do is we add water to this. What do? We add water to this. Now what happens when we dissolve this potassium permanganate? What do we do is when we dissolve this potassium permanganate in the water, now potassium permanganate is of violet color and water is already transparent, we come to know that this whole solution inside the water which we see, okay, this whole solution inside the water, it will change its color and the whole solution will turn to this color. So we can say that this potassium permanganate, the color is spreaded. Now what does this mean? This means that this potassium permanganate crystals occupied the whole solution. So this says that the whole thing become blue colored. The similar example is there of dissolving one solid in liquid. Suppose we have sugar. We take sugar and we dissolve it in water. Now what happens? Sugar is very sweet but water is not so sweet, but when we dissolve them we see that we have the sweet water, we see the sweet taste of water. Now this is again one example. You see, only the sugar was sweet, not the water, but now when we dissolve the sugar in water, the whole water became sweet in taste. What does this mean? These sugar crystals spreaded all over, means the sugar particles occupied whole of the water, which shows that these are in the motion. So these two things can prove easily. Now third experiment or one example we can say or we can take is of the gases. Now let us see that how the gases helps us to prove the theory that particles are in motion. Now see, we have this gas. This gas is known as bromine gas. What we did is we take two chambers, chamber number 1, chamber number 2. The two are separated by one wall. Now this chamber number 1 we filled with bromine gas and chamber number 2 is very normal. Now this red color shows that bromine gas is red in color. So we can write here that I can directly represent it like this way, that bromine gas is red in color. Okay, the bromine gas is red in color and here we have oxygen. And this is the bromine gas here. Okay, now what we are going to do is that now we are going to perforate this hole of the chamber. Means what we are going to do, this is our chamber. Now we are going to make holes in this chamber like this. Now what will happen is that eventually your bromine gas will become diluted and this will then now spread into whole of the two chambers. You will see that both the chambers became red colored. Now why did this happen? This shows that somewhere here also we have no bromine and here also we have bromine. This is chamber number 1, this is chamber number 2, and these are nothing but these are the slits that were already there. Now this shows that the bromine gas is spreaded. So this is showing that we have here spread of bromine gas. So this thing is again proof. It is proving that these bromine gas, all of the particles of bromine gases moved to the another chamber also, and there they spreaded over there. So this can easily show this thing, that how these things are taking place. So that's all for today.